When you hear the word rotation, take a second and think about what comes to mind when you hear that word rotation or rotate. A lot of times I'll hear students say a tire. Tires rotate, or they might say spin. Well, in math, that's exactly what a rotation is. So the rotations we're going to look at is when you turn a figure about a point. Now, for right now, the point that we're going to focus on rotating about is the origin in the coordinate plane. Now, a couple things come into mind and become important when we talk about rotations, which is not only what direction, because think about a tire, you can either spin it forward or you can spin it backwards, but also how far. So how far do you want to spin forward, or how far do you want to spin backwards? So all of those things do come into play with rotations. Rotations are a little bit weird in terms of in a coordinate plane, how we're going to take a look at moving ordered pairs and a figure in general. So if we take a look at a little bit of a visual there, so that's what we're going to do. We're going to take a shape from one quadrant and rotate it or spin it to a different quadrant. So you can see there in the middle they have that 90-degree angle, right? So we are going to spin in multiples of 90 degrees. And think about why we would do multiples of 90. If we're talking about the coordinate plane, a coordinate plane is divided by 90-degree sections. The first quadrant is a 90-degree right angle, the second quadrant a 90-degree, and so on. So when we look at rotating, we're going to go, again, multiples of 90. So if we were in quadrant 1, this particular rotation that you see going on there is a 90-degree counterclockwise direction. So it's going to spin that figure from quadrant 1 into quadrant 2. We could also spin in a 90-degree clockwise rotation. We could spin 180 degrees. 180 degrees, 90 times 2, so that would move us 2 quadrants. So let's go ahead and look at how we're going to do that within a coordinate plane. So this particular one, we're rotating 90 degrees clockwise. So clockwise, so if we look there, we have triangle A is where we start with. So -6, 4 is our ordered pair for A. And notice where A ends up after that rotation. So A is now at 4, 6. So notice what was a y coordinate, the 4, is now in the x coordinate spot. It stays the same value. It didn't change at all. It just flip-flopped the order. -6 was the x, and now +6 becomes the y. Think about in quadrant 2, all of your ordered pairs are negative and then positive. In quadrant 1, they're both positive. So if you're going to take an ordered pair from the second quadrant and spin it to the first quadrant, well, this negative somehow needs to become a positive. So we will have to take the opposite of that particular value. Spinning from the second quadrant into the first, again, opposite of that x coordinate, so now both of them become positive. If you notice, each one of those, B started at 1, 3. The 1 now comes to the opposite place, so it be from an x to a y, from a y to an x. And again, the opposite of what that x coordinate was. So this -6 becomes a +6. This +1 becomes a -1. Well, guess what happens then? A -3 becomes a +3. So the pattern, or if you will, the formula that we can use is flip-flop x and y. So x and y switch places. Y stays the same, and the x value is the opposite of what it started as. So again, think about spinning something from the second quadrant into the first. Just like in that picture, it would become the opposite. If we follow that same rule, doesn't matter what quadrant we start in, think about starting in the first quadrant. So those ordered pairs that started in the first quadrant, which was B here. B starts at 1, 3, both positive values. If we're spinning it into the fourth quadrant, in the fourth quadrant, X is positive, but Y is negative. Well, flip-flop, the 1 becomes the Y value and the opposite, making it -1, 3 becomes that X value. So the Y's need to be the opposite of what they started as, but the X stays the same. That's why that pattern or that formula is Y, comma, the opposite of X. 180 degrees, 2 quadrants. And notice it doesn't tell us what direction. There's a reason for that. When you're spinning 180 degrees, 2 quadrants, it doesn't matter what direction you go. If you were in quadrant 1, so if I take that point B and spin it clockwise 2 quadrants, 1, 2, there it is. Spin it the other direction 2 quadrants, 1, 2, it still ends up in that third quadrant no matter what. Any point, no matter what quadrant it starts in, 180 degrees, 2 quadrants is going to move you halfway around your coordinate plane, doesn't matter what direction. So notice what happens now. Again, same triangle, so our B still started at 1, 3. And notice where it is at after that 2 quadrant or 180 degree rotation. It's now at -1, -3. This time, X and Y both stay in the same spot. 1 still in that first spot, X, and 3 still in that second spot in for Y. The only thing we did is we took the opposite of both of them. From quadrant 1 to quadrant 3, in quadrant 1, X and Y are both positive. Well, in quadrant 3, X and Y are both negative. So we keep them where they were, just take the opposite of both. Let's see if that happened with A as well. It started at -6, 4. If we follow that same thing, take the opposite of both, it should be at 6, -4. And by golly, it is there at 6, -4. 2 quadrants. In quadrant 2, we have, again, remember, a negative, then a positive. But down in quadrant 4, we have a positive and then a negative. Well, they're opposites of one another, so you're taking the opposite of both of those. So that's our rule for 180 degree rotation. X and Y stay in their spots, just take the opposite of both of them. Our last one then is that 90 degree counterclockwise rotation. So here, if we go back to that nice little visual there, notice here, A is starting at 1, 2. Well, now it's at -2, 1. So yet again, just with the other 90 degree rotation, X and Y flip-flop places. However, this time you take the opposite of the other variable. So this time, X and Y still flip-flopping. Y stays what it was, or excuse me, X stays what it was. The Y has to become the opposite of what it started. Because again, if we started in quadrant 1, that 90 degree rotation counterclockwise, the X coordinate now needs to be negative, and it's the opposite of what the Y started as. So how do we remember those without actually memorizing those? Any 90 degree rotation, it doesn't matter what direction, X and Y flip-flop, always. Now here's where you have to think a little bit. In terms of your which one gets the opposite, think about what quadrant it started in. So if I started in quadrant 1, and that's probably the easiest place to think about, both of them are positive. But in quadrant 2, X is negative, Y is positive. So a counterclockwise, You have to, again, flip-flop, so y is coming first, but we have to take the opposite to make sure it gets negative. So the opposite of y, then the x. To spin into the fourth quadrant from there, and again, it holds true no matter what quadrant you started in, it just kind of makes sense to start in quadrant 1 where they're both positive. X is still positive, but that y value is negative. So for the clockwise rotation, flip-flopping x and y, x stays that positive, the y stays that, but then the x that we flip-flop needs to be the positive, the opposite one there. So let's go ahead and practice with some of those. So rotating about the origin 90 degrees clockwise. So remember, clockwise, x and y are going to flip-flop always. So y coming first, x coming second. Clockwise means we're going to spin that, think about it, from the first quadrant into the fourth quadrant. We would have to take our opposite of the x value because, again, the new y coordinate needs to be negative. So our a prime, we flip-flop, so the x becomes the 4 from the y, and then the opposite of our 2. Our b prime would be the y becomes the x, so 8 comma, now the opposite of that x value would become a positive 5. And c prime, the y coming first is 7, take the opposite of that x value would be a positive 3. 180 degree rotation, remember, opposite of both. Don't change where they come, they still come in the same order. Just take the opposite of both. So our new A would be at -2, -4, opposite of both of those. Our B prime, opposite of both, becomes a positive 5 and then a -8. And our C prime, positive 3 and -7. And for our last rotation, 90 degrees counterclockwise, again, always flip-flop x and y in terms of a 90 degree rotation. Counterclockwise, think about it. If we started in quadrant 1, both would be positive. Our new x value would need to be the opposite of what it started as. So the opposite of y, comma, x. So our new a prime, opposite of that 4, so -4. And then the x value becomes the y. B prime, opposite of y, so -8, and then the x drops in without changing. And your C prime would be -7, opposite of that y value, and then your x stays the same. So after that rotation about the origin, each one of those. So just following those patterns there, nothing different.